sponsored by Primer's new merchandise store on dftba.com. Link in the description below. This is a blob. It lives in a forest, eating mangoes and burning wood for heat. In this video, we're going to take the very first step toward building a simulated economy by creating a model for how this blob chooses to spend its time gathering resources. Each day, the blob can go out to collect mangoes and wood. Each tree produces 1 mango per day, and it grows back the next day if it gets chopped down. The blob's decision for how to spend its time has 2 inputs. First, what are its options for what to produce with the time it has in the day? And second, out of those options, what makes it the happiest? We'll start by looking at the production side. To figure out what these options are, let's see how many mangoes the blob can get if that's all it looks for the entire day. Alright, 17 mangoes total. Now let's try collecting only wood. It does take a moment to chop down a tree, so the blob probably won't get quite as many pieces of wood. Alright, looks about right, it got 14 total. Those are the 2 extreme cases, but what about cases when the blob tries to find some balance between the 2? We're dealing with 2 quantities, so it'll be useful to keep track of outcomes using a graph. The 2 cases we've looked at so far led to 17 mangoes and 0 wood, and 0 mangoes and 14 wood. Next, let's have the blob grab only 1 mango, and then spend the rest of its day on wood just to see how much it can get. Okay, it looks like we still get 14 pieces of wood, even if we sneak a mango in right away. And to finish putting this together, let's fast forward a bit and have the blob run through days, getting 2 mangoes, then 3 mangoes, then 4, and so on. Okay, assuming the only thing the blob can change is how much time it spends on each resource, these points represent all of the possible options. You might hear this called the production possibilities frontier. It's the frontier or the edge of what's possible. Or if we draw a curve through the points, the production possibilities curve. The curve really only makes sense when the numbers are big enough for it to look continuous though. With all that done, we have a pretty good understanding what the blob is able to produce and what trade-offs it has available. But we don't yet have any idea what the blob wants to produce and which trade-offs it's willing to make. Maybe the blob wants to balance its time to get a decent amount of both mangoes and wood. Or maybe it doesn't care about wood at all and it just wants as many mangoes as it can get. So now our goal is to make a computer model that captures the full depth of the human experience. How can we do that? Well, I certainly can't, but we don't have to be quite that ambitious. All we need here is a way for the blob to choose which of 2 situations it prefers. So, and this might sound a bit silly at first, we're going to try to give a happiness score to every possible combination of mangoes and logs. Then, when the blob has a decision to make, it can just compare those happiness scores and pick the higher one. Again, we'll start with just mangoes. Also again, we'll use a graph to keep track of things. So what should the happiness score be for 1 mango in a day? We're making this up, so let's just say 100. That's pretty meaningless on its own, but what about the second mango? That first mango stopped the blob from starving, which is pretty valuable. So even though the second mango is still delicious and nourishing, the blob isn't quite as desperate for a mango now that it's already eaten one and it's not gonna starve. And so that second mango will give fewer happiness points, say here, about 60 for a total of 160. And this trend will continue with each mango being worth a little bit less than the previous one. The term for this is diminishing returns. Sometimes people use the word utility to talk about happiness points, so you might hear this called diminishing marginal utility, which just means you get fewer happiness points for each additional mango, or whatever it is you're talking about. That's the basic picture, but we're going to want to adjust these values a few times, so instead of making up each number individually, I used a logarithm function to get the values. If the word logarithm makes your head hurt, don't worry, we're not going to go too deeply into them. It's just a kind of function that follows this idea of diminishing returns. It's actually the opposite or the inverse of an exponential. When things grow exponentially, they grow more and more and more quickly, and when things grow logarithmically, they grow more and more and more slowly. And that slowing growth is all we're looking for here. All right, and before we keep moving, we should note that this utility function is an assumption. Maybe the first one just wakes up the blob's palate and the second one is amazing, and so it's worth more than 100 happiness points. And then eventually the blob gets full and eats too many, making its total happiness actually go down, which is known in some circles as the mo money mo problems effect. Or in my case, it's the Taco Bell drive-thru phenomenon. And Taco Bell, if you're watching, I'm always looking for new sponsors. Anyway, there's a whole field called behavioral economics that focuses on how people make decisions. So we'll explore more models in the future, but this idea of diminishing returns is a pretty decent starting point. All right, now let's add wood to the picture. At first, we'll assume the blob values wood in the same way it values mangoes. Now our happiness point function has 2 inputs and 1 output. So to show it in the graph, we need to add another axis for wood. And now instead of a curve, we have a surface. Any combination of mangoes and wood leads to some point on this surface, and that point's height reflects how happy the blob is with that situation. And that's how the blob decides what it wants. In a minute, we'll combine it with the production possibilities, but I've thrown kind of a lot at you over the past few minutes, so don't be shy about pausing, rewinding, and re-explaining it to yourself to help it all sink in. Now we have everything we need to unleash this blob and see how it behaves. It'll start by just getting 1 mango before switching to logs, and each day it'll adjust how many mangoes it goes for until it seems to find the strategy that gives the highest possible number of happiness points. This is the same forest, the same blob, so the production possibilities are the same as before. So if we wanted, we could just have the blob calculate the optimal point ahead of time. But in real life, we have to try things out and learn from our mistakes, and so we're gonna make the blob do the same thing. Alright, so it looks like the blob is equally happy with 10 mangoes and 9 pieces of wood, or with 9 mangoes and 10 pieces of wood. It's not too surprising to see that it's finding a happy medium since the 2 resources are valued in the same way, and they aren't too different in terms of production possibilities either. But now what happens if the blob has a little baby blob? The baby can't collect anything, but it does have to eat. So now let's say the blob values mangoes twice as much as it used to. What do you think the new optimal strategy will be? It turns out that 13 mangoes and 6 pieces of wood ends up maximizing the blob's utility. The interesting thing here is that even though we literally and precisely doubled the value of mangoes, it didn't try to get twice as many mangoes. All right, one more situation before we go. Let's rewind to before the baby blob came along. So now the blob is back to valuing wood and mangoes in the same way. This time though, each mango tree will bear 2 mangoes each day instead of just 1. And with the different forest, the production possibilities will actually change. Now what do you think the blob will do? And we've landed on 12 mangoes and 10 pieces of wood. It could have been natural to guess that the blob would get twice as many mangoes, but the blob ended up deciding to get only a few more mangoes and then use the time it saved to get more wood. And the way I make sense of this intuitively is to think about if, say, a cheesy gordita crunch was half the price. I wouldn't actually eat twice as many. I mean, don't get me wrong, I'd eat more, but I'd probably put some of those savings into buying a bigger Baja Blast, which it comes in a 0-calorie version now, by the way. The point is, it's hard to predict ahead of time how everything's going to balance out when you make one simple change. That's it for this video. In the next video, we'll expand this economy by introducing this blob to its neighbor, and we'll get to see whether they decide to trade with each other. See you then.